So if you encounter a variable that's x with nothing above it, that bit of information you're assuming is a scalar. If you encounter x with an arrow over it, that bit of information you're assuming is a vector. Okay? So momentum is given by the letter P for historical reasons, and it would be P with an arrow over it. So I could rewrite this equation as P, one initial, one I. So this is the initial situation, and it would have an arrow over it because it's a vector, plus P 2I. This is the initial momentum of object 2 equals P 1 final, the final momentum, plus P 2 final. So that's another way of writing that equation. It's much more compact.
Is that I
I for
algebra?
the initial
Oh, okay.
state and F for the final state. Okay? You could also use B and A, like for before and after. Okay? Components are given by single numbers. Okay? The vector for velocity, which by the way is given by the letter V. So it would be V with an arrow over it. The velocity is composed of two numbers, but the components themselves are scalars. Okay? So we would typically write the x component of any vector as the variable of the vector with the subscript x. So I would write this as v with the subscript x. That's the x component. And then the y component would be v with the subscript y. And there are no arrows over top because components are scalars. They're given by a single number. Okay? And the vector, you can just write this in parentheses. That's a perfectly acceptable notation for vectors. So I could write this as 31.7 miles per hour, comma, 14.8 miles per hour. For any vector A, the x component is given by A with the subscript x. The y component is given by A with the subscript y. And there's one more number. I'm missing the magnitude. Is the magnitude a scalar or a vector? The magnitude is a scalar. Magnitude is just one number, right? It's just how long the vector is, it's just the length of the vector. The magnitude of the vector can be given in two forms. So, and the magnitude is given by, either you give it by the letter plane with no arrow over, or you can write it as the letter with the arrow and then put the absolute value sign on it. Either of those implies the magnitude. Okay? This is the simpler notation, but this one is more explicit. This is explicitly saying the magnitude of the vector A. Okay? So I could rewrite these two equations in the more proper notation that we just have right here. So instead of writing y equals 35 sine of 25 degrees, I would say that the y component of the velocity equals 35, and 35 is the magnitude, so it equals v sine of 25 degrees. That's the way to represent this in variables. And then here, the x component vx is v cosine of 25 degrees. We'll work on notation more at the start of the next class. Okay, but we're gonna have to start getting used to the notation because look at how long this equation took to write out. You don't wanna write equations in words. You wanna write them in a compact notation. This took me a while to write, this takes no time at all to write. Okay, so we're gonna work on notation more at the start of next class. Are there any questions? All right, that's it for today, guys. Where's the sign-in sheet? If anyone didn't sign in, don't forget to sign in before you go. And that's it. Have a good one.
Anybody want to give the number for the WhatsApp?
No, syllabus is on my website. It's not on. My website is www.pla.com. And at the top, you click on teaching. And then under teaching, it's spring.
Yeah.
And the class is line 153. That's the syllabus. The grades, I will give you back your exam grades. Homework, your grade will appear on your final grade will appear in your student portal.
Is that
However,
it? Thank you.
no, not for this class.
No problem.
Yeah. Okay. So there are no overrides for labs. There are safety rules that limit the number of people that you can have per lab. Yeah, this is OSHA laws. So search for the week. If anyone doesn't show up to the first lab, they're automatically dropped from it. So